So I said, we've got to put it on an engine dyno and then find out what the hell's going on. And we found it straight away. When the engine was at like 20% throttle, this thing was detonating its head off. And that's what it was, because Alistair McRae was like full throttle everywhere, even road sections and whatever. We never had that problem. And of course, Higgins was trying to be gentle, road sections. The damage was happening. And then as soon as you get on the stage, bang, that would be the sign off of the piston.
Welcome to the HPA Tuned In podcast. I'm Andre, your host, and in this episode, we're joined by David Rowe from EPS Motorsport in the UK. I first met David around about 5 years ago when I was attending the Pikes Peak International Hill Climb. And at that point, Dave was competing with his absolutely immaculate Audi Group B rally car replica. This was a replica in the sense that it looked like the original, but the attention to detail, the modernisation was at another level, and this attention to detail really goes through everything that David does. In this episode, we dive deep into David's history, how he got involved in cars, his time spent learning his trade and honing his skills at MoTeC, both in Australia and then at MoTeC in Europe. Of particular interest in this episode is some of the projects that David finds himself involved in. Given that he's built himself an enviable reputation throughout Europe, he finds himself involved in some pretty interesting projects modernising the electronics and taking over the tuning duties on the dyno. I'm talking here projects such as a Sauber Mercedes 96 Group C race car, where he retrofitted the entire wiring harness and modernised the electronics with a MoTeC ECU. Despite these cars being worth upwards of about £2.5 million, these are still raced hard and power is still important. So don't think this is some detuned dyno queen. It gets driven hard. On top of this, there's not too many people we get to talk to who've had the opportunity to tune not one, but actually several Formula One engines. We dive into that as well. Lastly, for those who are interested in the business side of the automotive and specifically the tuning industry, we get to pick David's brain on that side of things as well. So there's a huge amount of information covering a really wide range of ground here. Before we do get into our interview with David, though, for those who are fresh to the Tuned In podcast, High Performance Academy is an online training school. We specialize in teaching people how to tune factory and aftermarket engine management systems, build reliable race and performance street engines, build your own wiring harnesses. We also cover topics including race driver education, car setup, and data analysis, just to name a few. You can find a complete list of all of our courses at hpacademy.com/courses relevant to today's topic, considering we are focusing fairly squarely on the tuning side of things, is a few of our tuning courses. We'll start here with our EFI Tuning Fundamentals course. As its name suggests, this covers the fundamentals of EFI tuning. You'll learn how the engine works, how the ECU works, how it calculates the required fuel, what we're trying to do when we're delivering fuel, and as well what happens with the ignition event, how that affects the way the engine performs. If you want to go a little bit deeper, we also have our Understanding Air-Fuel Ratio course, probably one of the most misunderstood concepts in the world of EFI tuning. You'll learn what the air-fuel ratio actually is, why we need a specific amount of fuel, how the air-fuel ratio affects the engine operation. We'll give you some safe starting air-fuel ratios for a range of different engines, and then most importantly, teach you how to test and find the ultimate air-fuel ratio for your particular engine. Then we dive into our practical standalone ECU tuning course. As its name would suggest, this will teach you how to tune an aftermarket standalone ECU. Doesn't matter the brand, all of the lessons 100% applicable. We know that when it comes to tuning your first ECU, it can be a bit daunting when you're faced with no start file, no base map. And interestingly, we'll talk about the irrelevance of base maps and start files in this chat with David as well, but I digress. We teach you how to build all of that yourself, and we've broken the entire tuning process down into the HPA 10-step process. By doing this, each of those steps relatively easy and quick to complete. In no time, you've got a properly tuned engine delivering great power, torque, and most importantly, great reliability. This course also includes a library of worked examples where you can watch that 10-step process being applied from start to finish on a real tuning job. We vary the type of engine as well as the ECU we are using to give you a broad range of experience. As a podcast listener, you can also use the coupon code podcast75. That will get you $75 off the purchase of your very first HPA course, and we'll put a link to all of that in the description. All right, enough of our introduction. Let's get into our chat now. All right, welcome to the podcast, Dave. Thanks for joining us today. And as we usually do, I just wanted to get started by learning a little bit about your background and specifically how you got involved in the automotive scene right at the get-go.
Yeah, my name is David Rowe. I'm originally from Melbourne, Australia. And basically I started training as a motor mechanic when I left school. So, that was a great stepping stone for the industry I'm in today, really, which you can't believe how you go back on the early days of training of being a motor mechanic and apply that to your current job now. So we sort of done that when I left school. And then after that, I also got a job at a company which done some fabrication for rally cars and some race cars. So we dabbled in a bit of fabrication of rally cars and race cars for a couple of years, which was great knowledge as well. We got to learn to weld and, do all sorts of things. We were fitting old Wolf 2D ignition-only computers back then, all sorts of stuff, So it was amazing what we sort of learnt there as well. And then after that, we got a job at MoTeC in Melbourne at their head office. So they applied for a technician, and that was basically in sort of the workshop, and we were doing everything from like assembling throttle bodies to doing customer support and manufacturing wiring harnesses. And so it was a really good stepping stone for what I wanted to do for the future, really. So I couldn't have asked for some better training, really. So
just coming back a step, there's a lot of obviously mechanics out there all around the world who train to become a mechanic and by all accounts probably very, very good at what they do, but maybe don't have that passion for actual motorsport. Maybe they're not modifying their own cars, etc. Was there a little bit more to your sort of drive in the automotive industry other than just spinning spanners to make a dollar?
Yeah, correct. I mean, as a sideline, my father was always heavily involved in sort of motor racing and sort of, playing around with cars and tinkering and stuff like that. And that's where our passion and love affair come with it as well. So, from the age of 15, we were racing go-karts. And then from like right up till like 19, then we got into circuit racing. I was also co-driving for a friend with his rally cars. So, one weekend we'll be circuit racing, next weekend I'll be co-driving. And then during the weekdays, I'd be sort of helping out prepping of rally cars and, race cars. And also, my brother was a massive petrol head as well, and all my mates were. So it was kind of just something he did, really. I just, I used to love it. Used to, you'd spend all your money on car parts. And to be fair, not a lot's really changed, to be honest. So
just though car parts become a bit more expensive.
Yeah, that's right. Yeah. And apparently if you sell them, at some stage of your life, that's meant to help as well, but I haven't mastered that talent.
All right, let's sort of come back to the stepping stone up to MoTeC. I mean, most of the listeners of this podcast would have heard of the brand, one of Australia's premier ECU manufacturers. So prior to moving to MoTeC, you'd sort of said you dabbled in some Wolf 2D ignition ECU. So for those who haven't heard that brand, I don't hear it a lot. I've dealt with it a couple of times over my career, but Wolf is another Australian brand. I don't really know why Australia kind of ended up being this melting pot for ECU manufacturers. a bit of a tangent, but there's a huge number of aftermarket ECU manufacturers in Australia, probably per capita, I would guess, higher than anywhere else in the world. I mean, on that note, is there something in the water over there? Is it the crocodiles? I don't know. Why is Australia kind of that hotbed for ECUs?
I think it's much the same as your country, really, Andre. It's like we tend to like not to buy most things. We try to make it ourselves half the time, don't we? So, as far as trying to buy an ECU or whatever, I'm sure there was like, well, I'm sure Bazza or whatever can make an ECU for us and can kind of evolve it from there. And that's kind of how there were so many ECU manufacturers in Australia, wasn't there? There was like the Autronics, there was Wolf, there was Haltech. There's numbers of ECUs. Yeah, that's right. Yeah.
All right. So to bring us back on track after that little tangent there, you said you dealt with the Wolf 2D ignition only ECU. So obviously you're sort of building maybe a very small amount of experience at that point. How pivotal or important was that to getting the job at MoTeC? Is there sort of a deep-seated interest at this point in getting more involved in the ECU tuning side of things, or are you still more involved or interested in the mechanical and fabrication side of automotive industry? To
be honest, it was quite a pivotal point, really, because when you like tune an engine or you make something, you adapt electronics to a vehicle and it runs for the first time, and it's so rewarding and enjoyable, isn't it? It's kind of instantaneous, the feeling you get from, the results that you achieve, isn't it? And
yeah, absolutely.
And for me, it's like another stepping stone, isn't it? Because when you go into a career or any career, isn't it? You always want to be intellectually stimulated. And I kind of figured that like this industry was like endless, and it was kind of at its probably infancy, really, wasn't it?
What year are we talking about with your move to MoTeC, just so we can get a bit of a sense?
It's probably like 95, 96 it was, yeah.
I was actually just going to say, I think just from my own experience, and a lot of our listeners probably a bit younger would have missed that what I call the golden years of the aftermarket ECU industry, the 90s and into the 2000s, when the crop of cars that were coming through were not as advanced as what we see now. And by that I mean CAN bus with multiple ECUs controlling different parts of the car just wasn't really a thing. So plug and play ECUs were relatively quick and easy for manufacturers to make. So it just gave us quite cost-effective access to tuning tools to actually absolutely transform a car with a minimal amount of effort. We don't really need to go and make a complete wiring harness. And obviously, as time's gone by, we've moved away from that a little bit. It's much more difficult to do that, albeit obviously not impossible. I'll also mention, your point about getting an engine running, it is really rewarding. And particularly, I think, with the larger projects out there as well, you might have been working on a project car for a year or more, and it doesn't really seem like there's a lot of progress, and it can be really easy to get disheartened. And I've always found with the bigger projects we worked on at my old shop, at that point where you get to start the engine for the first time, and there might still be 6 or 12 months of work ahead before it rolls out the door, but that just reinvigorates the whole team, and it's just like, okay, I can see the light at the end of the tunnel now, let's go. So that is a really important part of any build, I think. Obviously, as tuners, we get to experience that firsthand time and time again. All right, let's get back to MoTeC. So, I mean, you probably couldn't go to a better place to learn about tuning. So talk about that evolution and your own experience and how you moved from mechanical and fabrication more into the electronic side of things.
Yeah, that was a major, sort of career move for me, that. And of course, when, back in like 95, etc., you weren't really, computer savvy compared to what sort of teenagers or anybody is, nowadays. You didn't really, I even lied on a job interview about, I know about Windows and Excel, DOS, know all that. That's fine, And I absolutely crapped myself because I had to go home and tell my dad to teach me how to use a computer before I started my job at MoTeC,
Fake it till you make it.
100%. I'm still doing it today. No. To be honest, like, it was something that you could associate with, cars and cool stuff, with the use of a laptop, because back then, laptops weren't as advanced as they are today, and they were quite clunky and hard to use and stuff like that. And I mean, when I first started MoTeC, it was all MS-DOS, like it was the old M4 days. It was the M48 and the holy grail, the M8 ECU. Like, they were the things to have, and we had like i2 Pro, which was designed and built by the general manager at the time, Ken Douglas. Like, Ken Douglas was a manager at MoTeC, and he wrote i2 Pro. So he was managing the place and also writing the code to make the software and data logging analysis tool. Like, that's how small the company potentially was. And then, my God, the M800 come out, and that was like another level, that was. And the early M800 ECUs from MoTeC, even they were MS-DOS, weren't they? They only, like, I think it was version 2 software. They went to like a Windows-based.
I do recall I had an M48 back in my Evo drag car back in the day, and after going to the M800 with the Windows software, every time I had the displeasure, I'd call it now, of turning an M4 or an M8, you sort of shook your head, that DOS interface. I mean, it was just what it was at the time, sign of the times. But it's very frustrating when you go back, and I think now on Windows 10 machine, it's actually just about an impossibility to tune the older M4s, etc. Makes it very difficult.
Yeah, 100%. And you had to earn your money, didn't you? You couldn't just highlight a group of cells and increase the numbers, decrease it. It was like manually page up and down, and my God, your fingers would go home sore, if you had a big day on the dyno, so to speak. So
yeah, the advent of being able to select a group of cells and sort of make an across the board change was definitely a game changer. I mean, stuff we take for granted on just about any ECU these days, but just for the tuner, the workflow, particularly if you're making wholesale changes to an existing map, was absolutely amazing. All right, so to talk to us about the evolution of your sort of knowledge on tuning, how did you get started with that? What was your sort of roles at MoTeC?
We were involved in like customer support, and also we were doing development of products, at MoTeC. So we would, for instance, like the Nissan Pulsar GTIR was current, wasn't it? It was a new thing, and we had one of those. We had to like find wiring diagrams, and we had to hack a plug off and make a plug and play. And then we had to like reverse engineer the cam sensor, the crank sensor combination. And then like some code would be then written to make a ref sync mode for the crank trigger assembly. And then we'd also then make diagrams available, and then a start map available for the dealer network and all this sort of stuff. So it was those sort of projects really that we sort of got involved in sort of tuning really. And there was all sorts of applications where you would learn all the time, because, at the time I was working a lot with Rally Art in Australia, back with like Ed Ordinsky and, back in the old Evolution 5 and 6 days and stuff like that. So we'd do some like mapping with them, and we'd sort of like, have different anti-lag strategies, and we'd do testing. And I think that's something you've got to really put a value on, is your relationships that you do have with some of your customers. And when you do have a good long-term relationship with a customer in a particular discipline, whether it be drag racing or historic sports car racing or whatever, then your skill level and fine-tuning of that particular engine or discipline, it becomes, first class really.
I think that's a really good point that most people probably would disregard. But I mean, as a professional tuner, you're kind of limited to the experience that your customers provide. And what I mean by that, you get access obviously to the engines that are brought to you. and the disciplines, the types of motorsport that those customers are involved in. And I mean, I was very fortunate that my own drag car performed pretty well on the world stage, which gave me then access to other very high level drag cars. But by being able to tune these very high level drag cars, that gave me experience that would have been very, very difficult to get otherwise. And it would have been almost an impossibility if I was only learning on my own car. So just each of those individual experiences just expands your knowledge so dramatically, gives you insight into other tools and applications, etc. So I think that's really important to sort of embrace that side of things. At what point did you sort of decide to actually do your own thing? And I mean, obviously there's a bit of a transition here because you've moved from Melbourne across the UK as well, which on face value, I hear the weather's lovely in the UK. For an Australian, seems like maybe an unusual choice. So tell us about that.
Yeah, it was always too hot in Australia, so I decided to, move somewhere a bit colder, really. So, but no, I went from MoTeC Australia to MoTeC Europe. So, MoTeC Europe had a position available, which was for a technician, much the same role as in Australia, but it was more track support orientated. And back in its infancy, we were doing a lot of like tuning itself, as a service from MoTeC Europe. We're doing like a lot of dealership support for dealers, in different industries.
I guess on that note as well, Australia is definitely got a very, very active motorsport industry. However, kind of the pinnacle really in Australia is the Supercars series, which is a great series. When you compare that to the sort of level of motorsport in Europe at the higher end, I mean, you've got access to anything and everything. So is that sort of a key to expanding your skill set and knowledge as well, getting access to all of those sorts of vehicles?
Yeah, 100%. And that is the main key of being in Europe, really, or England. And, like 10 minutes down the road, I'm at Silverstone. I can be at many, many race circuits, within hours from where I am. We've got lots of World Rally Championship teams. We've got lots of GT teams. There's go-karts up the corner. There's lots and lots of different sort of motorsport disciplines over here. And they're all, at a massively high level. So you look into you've got British touring cars, you've got LMP cars, you've got the historic side of things. It's just a much bigger industry over here, isn't it?
I guess the other element with that is, I mean, if you look at the pinnacle, obviously you've got F1, and the majority, or at least a large number of the F1 teams are, from what I understand, all located in and about sort of one relatively small area of the UK. And it's not only that though, but because those teams are all located there, all of the supporting manufacturers of components, parts, etc., kind of end up growing up around them as well. So again, just access very easily in close proximity to all of those companies.
Yeah, it's amazing. When you first sort of come to England, it's really hard to know the law of the land as far as like where stuff's located and whatever. But it's amazing when you've been here for a little while that the amount of tuning shops or engineering shops all hidden across the country. They're absolutely phenomenal. You could walk into somebody's barn and there'll be like an old Formula One car and, a Group B rally car or something like that. And, it still surprises me to this day, really. So it's quite refreshing to be located here. And of course, I was traveling loads. I was doing something like, I think 140 or 160 flights per year, just sort of cruising around the world, just pissing about tuning cars, So
on the note you mentioned about sort of the cars hidden away, I do remember it was 2019, we headed over to the Goodwood Festival of Speed, and we bumped into you over there, and we did a bit of a tour around after that and visited the likes of Renvale, who do the wiring harnesses for almost every F1 team. And we, on the last day, we had a bit of spare time, and someone had suggested we go and visit Jeff Page, which was a name at the time I didn't recognise, but pivotal in the Ford RS200 era. But walking into his workshop, which I don't even think there was a sign out, it was just nothing to look at, and walk in there, and he was working away a week before the Silverstone Grand Prix on I think one of Ayrton Senna's original F1 cars, a car that's literally got no value. You couldn't put a number on it, and there's Hart 415T original F1 turbo motors sitting there. There's the Cosworth V6 turbo engine. It was just mind-blowing. So this is the sort of stuff I guess you see all across the UK. However, I digress. So how long were you involved with MoTeC Europe, and at what point did you decide, hey, you know what, let's make a go of this and start my own company?
Yeah, I worked for MoTeC Europe for 9 years, and I loved every minute of it, really. And there becomes a time when you sort of want to be your own boss, don't you? Because you want to perhaps do other things, and also as well, you end up going a bit sort of numb to the day-to-day grind of things, don't you? So, for me, I wanted to keep the old intellectual stimulation going and, become a small business owner, so to speak, and then run my own thing, really. So that's when EPS was formed, Electronic Performance Systems, and we're a distributor for MoTeC products, which is probably 90% of the business. And then, we're big dealers of motorsport sensors from KA, and we do ASNI performance products and Turbo Smart as well. And that's kind of the business model, because I can kind of just get on and do most things ourselves. I'm sitting here in my wiring loom bench in my house. I could make my own looms. I've got a friend down the road that's got a rolling road that we can hire for a reasonable rate. So whenever we need to do any sort of mapping and calibration work, instead of trying to kill yourself on the street, we sort of tend to use the rolling road and get good results, because everything's proven then, isn't it? You've got something to reference to, and you can't lie with a dyno if you run it right. So, it's definitely the way forward, really. So that's kind of what we do now.
Okay. I want to dive into the dyno element specifically shortly, but before we do that, just to wrap up what EPS is at this point in time, is it just you, or do you have staff? And what sort of cars are you working on? Is it exclusively race cars, or you basically anything that comes through the door? Yeah,
it's just me. So we do the accounts, we do everything, really. So there's just myself that runs the company and does everything. So probably most of it by default is motorsport related business. I do some road cars, but we signed a lot of NDAs, so we tend to do projects for other companies that people don't want people to know about, or to know that we're involved with, which is fine.
By definition, we can't talk about those.
Pretty much, yeah. You just got to wear a plain black T-shirt and go to work and just sort of do those. So they're kind of interesting as well. And I don't mind, like if you've got a big company and you need a bit of a hand, which we all sometimes do, don't we? It's good to get a bit of a hand or a second opinion with some stuff. So we sort of get us involved and we sort of help people along the way, really. So I quite enjoy that, to be fair. So
I just want to dive into the business element just briefly, because I think a lot of people kind of are good at something, be it tuning or fabrication or just spinning spanners, and they decide, hey, you know what, I'm sick of working for a boss, so I'm going to start my own company and do this. And you could be the best in the world at whatever that discipline may be, And at least in my experience, this is exactly how I sort of started out. I kind of fell into a role of I'm going to open a tuning shop. And what I quickly found, particularly if you sort of have a bit of a reputation and you end up with a lot of inquiries, is, in your 8-hour working day, or let's be honest, it's probably more like a 12-hour working day when you're getting started, you only probably have about a third of that time available where you can do the job that you enjoy, that you're good at. And then the bit that's easy to miss is that the rest of the time you're dealing with customers, you're invoicing, you're doing your accounts, dealing with suppliers, quoting out jobs. And that part, I mean, at least for me, was not my preferred sort of aspect of the job. But it's also, when you're doing that, it's a necessary part of it, but it's also very difficult because you're not actually making money. And that's where a lot of companies sort of get to a point where they're going to bring someone else in to do that job, the accounting or the customer service side of things. And that's sort of that natural expansion a lot of people go through. So how have you dealt with that? How do you sort of balance that?
I totally get what you're saying with that, because nowadays there's so many multimedia platforms where people can get in contact with you, WhatsApp, emails, this, that, blah, blah, blah. And sometimes it becomes too much, really, doesn't it? And you often see this with my replies to emails, really, of massive long. People would send me a page-long essay of blah, 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 and I'll send them one line back. So, because you just haven't got time, have you, to spend, telling war and peace, to some customers, like I'd rather just pick up the phone and just like, dude, speak to me. Let's get some one-to-one conversation going about your project. And then, we can sort of cut out all the bullshit, because I hate spending hours and hours behind a keyboard or whatever, because some days you're just so mentally drained of if you're sitting with somebody's project, and a lot of these cars are worth a lot of money, aren't they? And for the money you charge, it's peanuts compared to the value that you potentially bring to the project. And, and I had one guy, I was dyno in his car with him, and I'm quite open with all the dynos and anything that I do with customers. If you want to sit in a car with me while I tune your car, we can talk and whatever. And this particular guy was, I always remember this, because he's like, oh my God, Dave, you never answer your phone. And I said, well, I'm sorry, but a lot of people pay me a lot of money to concentrate on their project so that we can, make sure that everything's all right. And he's gone, oh no, that's no excuse. I said, that's fine. Okay. And we started getting into the car, and anyhow, my phone rang. I said, hang on a minute, turn off the engine, answer the phone, David Rowe, EPS Motorsport. And there's like, and then, okay, ready to go again. And then he's like, okay, you're right. And he's like, yeah. And then we started again. Then, sorry, phone's ringing again. And he goes, I get the point.
It's hard to sort of focus on doing the job when your phone's ringing off the hook. And I think what I saw as well, and it's probably worse now. I mean, back when I was running my shop, Instagram wasn't a thing. WhatsApp wasn't really around. But now there's so many mediums where the customer can reach out. And I think as well, sort of barriers kind of get lost. I mean, I distinctly remember getting text messages at 10 o'clock on a Saturday night, and I'm out with my friends, my car won't something or other, something's not working. Yeah, okay, cool, well, let's talk about that at 8 o'clock on Monday morning. For now, I'm done. But I mean, that is part and parcel of it. A couple of other things just on the business front as well. At least what I've sort of seen for the most part around the world, I think it's probably safe to say it goes around the world, is there's sort of a race to the bottom almost in terms of what people are charging for a service. And this goes with products as well. Aftermarket products, generally, there's a fairly meager margin for the workshop on supplying a part. And you've got a lot of companies now supplying parts, and maybe it's a part-time job, and they're okay if they make $50 on a blow-off valve or a wastegate, for example. But for a workshop, that's probably not acceptable. So the first question there is, how do you sort of work with that when there's people out there selling essentially the same product or similar products and are prepared to do it for next to no margin?
I think that's what people have got to realise. When you buy a certain part for your car, like that might be just bolt on and forget. But when you buy something that's potentially so technically involved, you've got to value the support and service that you'll potentially receive from the person that you buy it from. So if you go and buy an aftermarket ECU from eBay, then expect somebody to just like, oh yeah, I'll fit that for you. Oh yeah, I'll take your call on Sunday at 10 o'clock at night. It just ain't going to happen, is it? And that's potentially what you get a lot of, isn't it? You kind of get that. And I know when I first started EPS, like one of my customers that was really influential in like business and personal, he mentioned, like, why are you so busy? And I sort of replied, well, I'm just trying to make everybody happy, aren't I? And he said, well, don't. He goes, you need to cut 25% of your business. And that's what the road that we went down, and we did. And he said, just write on a whiteboard all the things you do and what they bring to the company, whether it be money, value, grief, whatever. He said, write them all down on the whiteboard. And he goes, it'll be soon evident of what really winds you up and brings you, sort of no potential income and takes up a lot of your time.
That's a really important element that is not obvious. I think pretty much comes back to the Pareto's principle, the 80-20 rule. Sort of 80% of your sort of success, be that income, whatever, is going to come from 20% of your efforts. If you don't realize that principle pretty much goes throughout business, throughout life, you're obviously not going to be looking for that 20%. I'll just kind of bring that back to my own experience. When I was running STM, we were dealing, initially I had a name in the Mitsubishi community, and that sort of transferred across to the Subaru community as well. And without trying to sort of pigeonhole young enthusiasts, what I found over time was we were getting a lot of cars that came in for tuning work, and that they'd book the car in, that's fine, we're going to tune it, it's X, Y, Z, and then the car would roll in and you look at it straight away and you're like, all right, so this actually needs about 20 hours of workshop work before it's ready to go anywhere near the dyno. And I'm talking intercoolers literally held into the car with race tape or cable ties, and it just did my head in. The problem was you had customers that had a misrepresentation of what they were going to get. Their expectations weren't matched with reality. When you're faced with a car that's sort of built at that level, you're not able to deliver a good product. So what we actually did, because that was so time consuming to get a result and it was hard to charge the work properly, was we sort of did a bit of a pivot with the business, and we actually focused on some of the later model vehicles. So here in New Zealand, that was the late model Holden and HSV. So for the US community, basically GM, LS, V8s, and also the later model Ford as well. And what we found, we were dealing with later model cars, much less cable ties holding the car together. So that was good. We could provide a good quality package of parts that we knew worked. It was tested. We knew it all fitted. There was no faff involved. But the most important thing was we could then put it on the dyno, and normally we could tell within 3 or 4 kilowatts what the result was going to be. The customer's stoked. We're also dealing generally with a slightly older clientele, had a little bit more money, so less of the champagne dreams and beer budget situation. So that was sort of my 80-20 sort of revelation. So sorry, I've sort of just walked all over the top of you there. So let's get back to your story with your mentor.
Yeah, that was the goal, and that's exactly what we done. Was we just sort of had a cull of, you never fall out with a customer, don't you? You try to let them fall out with you. So you try to either gradually perhaps just slightly increase your prices or, whatever, to sort of try to change direction on your business and stuff. And nowadays you can kind of do that as well with like your multimedia and other stuff, can't you? You know, if you want to tune Ferraris, you start posting stuff about Ferraris, don't you? You know, and you can manipulate, you know, what you sort of work on and stuff like that sometimes, you know. So that's, you know, kind of a good thing really. So, but back to like what you were saying about, you know, the expectations and stuff like that of some people, like, you know, you get some guys that can barely afford a car and, you know, the car that they're playing with. And just because you buy 800 horsepower turbo doesn't mean your car's going to make 800 horsepower, you know. So,
yeah, I think there's a big disconnect, unfortunately, thanks to social media and the car magazines back before social media was the sort of driving force. And I saw that mistake being made by so many customers, which kind of got to that situation I was talking about with the cable ties and the race tape. Yeah. And I don't want to knock the young enthusiast. I mean, I was there once upon a time, and no doubt you were yourself. You know, you're doing the best with the budget you've got, and it's always easy in hindsight. But at the time, you know, you're just going through doing the best you can. I mean, the advice I would probably give to those customers is just take a step back and understand, first of all, the overall budget of the project that you're trying to do. As you say, just buying the 800 horsepower turbo does not therefore make an 800 horsepower engine. There's so much more goes into it, which is easy to overlook when you're shopping for parts. And you know, by trying to do less with your budget, you're probably going to get a better result, be happier, be less stressed, and probably keep the workshop owner or the tuner probably smiling as well. Yeah. I'm interested if you can sort of share with us, if it's not sort of too sort of private, how do you charge your tuning out? Is it charged on an hourly rate, or are you charging out sort of this is what it's going to cost, and then if you want knock control, it's an additional. If you want cam control tune, it's an additional. You know, there's so many different ways.
I pretty much just charge like per day, you know, so I'm not interested in doing 5 cars a day, you know, none of that crap of, you know, like group bookings and like in and out. Yep. You know, I'd rather just do 1 car per day, book it into the dyno, and then it's like a fixed rate for the day hire, and then it's £60 per hour for the dyno hire, and then that's it really, and we kind of finish when we finish really. And sometimes you make it look too easy, don't you? Because you know, like you've kind of done, you know, probably 200 or 300 Mitsubishi Evolution 10 rally cars. You know, my God, I can tell you what injector time it should have. I can tell you what ignition it should have with, you know, what type of race fuel, etc. So, you know, some days you do make it look easy and it can be quite a quick day. Then other days you can be on the dyno for quite a long time, can't you?
Yeah.
You know?
Yeah. I mean, one of the changes I actually made back in my tuning business was we actually switched from charging an hourly rate for our tuning. There was an element where we still had to do that, but generally if we get a car in for a full tune, we actually charged a fixed amount for that car. And the reason we did that was some advice I ended up getting, which wasn't apparent to me at the time. You'd know yourself, and it pretty much comes back to your Mitsubishi Evolution story. The better you get as a tuner, the more experience you get, the faster you can do a tune. So you kind of, if you're charging on an hourly rate, it's almost a bit of a case of you're shooting yourself in the foot, because the better you get, the quicker the tune goes, the less money you make. So there's an element of that as well, which I think, you know, it isn't immediately obvious, because you're not really charging an hourly rate. You're charging for that experience, you know, the 10 or 15 years or whatever it's been in the industry doing that, seeing these same problems, seeing these same cars, and knowing, like you say, what timing that the engine's going to take for a given fuel injection timing, what sort of boost pressure it will take, etc. You know, what price do you put on that? So again, that's just an element that I embraced, and we are going pretty deep down the business side of this rabbit hole. So I want to come back and talk a little bit about some of the cool projects that I know you've been involved with over the years. And I think we initially met at Pikes Peak, where you're running your Audi Quattro Group B replica, which people want to find out more. We've got a tech tour of that car on our YouTube channel. We'll put some links in the show notes to that. But you know, as I followed you, you seem to be able to get your hands on some incredible machinery. When we were at Goodwood, you somehow managed to fluke the pleasure of having a drive in one of these cars, which was a Sauber Mercedes C9 Group C race car. Now, I'm guessing that car basically is priceless. You couldn't replace it, correct?
Correct. There was only a certain amount of chassis built. It was in a time of Group C racing was like on par with Formula One, and it was, like there are absolutely amazing cars. The speed that they used to, be able to circulate racetracks on, and also how quickly they developed as well. If you look at the different Group C cars from year to year, they were massively different. Although, like a lot of championship cars nowadays, you'll probably struggle to see the difference between one year to another. Whereas in the Group C era, it was a massive difference. They had crazy designers, which were all, rock stars in their own right, designing these cars, and they were developing engines, and they were sort of, producing parts and development parts that were, always getting, thrown at the car. And they were made to run long distances. Like you look at a Porsche 962 and you could get in one. They're nearly like a road car to drive. They're so user-friendly because they had to drive for 24 hours.
Despite the ability to run for 24 hours in endurance racing like Le Mans, these cars were incredibly powerful, correct? What sort of numbers were we talking for the Mercedes C9 that we're talking about here?
The C9, we sort of don't really run the car anymore, so we can tell you what sort of power it was making. But like on low power, we were 700, and then that was minimum boost. And then if we cranked it right up, it would run 930 horsepower. So, and then if you crank it up any more, it'd lift the heads off.
Okay. So a car like this, I'm assuming one of the problem is for those who are running these historic cars is the electronics in them now. We're talking circa late 1980s.
Yeah.
The electronics, first of all, very dated by modern standards, but I'm guessing it's probably not possible to get access to the software to even talk to and calibrate these older ECUs.
Yeah, correct. There's not many of the old boys that were around of those days that are still available today to modify and tune the cars. So they kind of wrote it into the rule book that electronics were free. So that allowed teams to then use a MoTeC, or heaven forbid they wanted to use anything else, they could use that as well, to, sort of run the car really. And that really opened it up to allow us to retrofit some of these cars to, make them, run as good as they can.
Now, with the car, again, just about priceless when we're talking about the dollar value of it and the historic significance of it as well. I'm guessing there's an onus of responsibility on you to basically retain as much of the historic accuracy, I guess, was what would be a way of explaining it, as possible, and also the ability, if required, to revert it to period correct how it was in the day. So when you're talking about an electronics retrofit, there's a couple of ways we could go about this. Obviously the cleanest way, I guess, is to just fully rewire the entire car, but that's a pretty big job. Alternatively, we could repin the connector for the ECU that was on it for an aftermarket ECU like a MoTeC. What's your philosophy there, and how are you doing this?
To be honest, that's, like what you first said about completely rewiring the car and starting again from scratch. That's pretty much what we do with most of the cars. We tend to, it's a lot more involved in a car like that because you still want to use some of the old dash switches, the rotary pots that they used to use to change the map selection or boost levels. The old oil lights, you want them to light up for, warnings and all sorts of stuff like that, really. So, yes, there is some compromises, because you can't just whack a electronic drive-by-wire throttle on a Group C car. They just weren't like that back in the day. Like the cars were always warmed up in the pits by the mechanics, held at a high idle speed, blah, blah, blah. So, you're still being very sympathetic to how the cars actually should be run in period, because the old wastegates, on the C9, they're a massive plenum chamber, and doing the boost control on that compared to like a modern turbo smart racegate is light and day difference. It's just not going to be as good, with a modern wastegate on it. But it kind of is what it is. For the wastegates, for instance, although they look old and big in period, like certainly on the inside of them, they're a different story. We can kind of put an aluminium insert in there, and we could sort of reduce the volume of compressed air that you can sort of give it, so the response time's then better, for the boost control, and you could sort of modify things in that sort of respect to then get the best out of both worlds, really. So
make them as good as they can be while still retaining that period correctness.
Yeah, 100%. And as we said about the power levels of the car, you really want to make them drivable as well, because, a lot of these guys are gentleman drivers, aren't they? They're not Michael Schumacher, some of our Group C drivers, their diet's a bloody cheese board, so they just want to have some fun in their race car, and, they're not athletes.
Not at the peak of athletic ability.
No, so we kind of try to make it as user-friendly with the modern management system, and, like turbo boost control with throttle position dependent and also speed dependent, so that way you can really make the car nice and mild in the lower gears, and then part throttles, it doesn't try to kill you and all this sort of stuff. So that's the joy of what you sort of have available, really.
Couple of things there. I think most people, when they're considering what happens on a dyno, are thinking about the power and the torque number. But what you've just mentioned there, I believe, is so much more critical, particularly with a very high-powered engine. And I've talked about this on the podcast numerous times, but particularly that ability to map the lights of our boost pressure versus throttle position, because if we don't do that, the turbo is so good at making boost pressure that we can pull the throttle back to 50% or thereabouts, and you're probably still making upwards of 80, maybe 90% of the engine's peak torque that you got at wide open throttle. So it gives a very non-linear torque modulation to the driver, which particularly for non-professional drivers with a very powerful engine, that can be very difficult to manage. Now, on that front, I can only imagine that back in 87, whatever it was, the ECUs available to Sauber were probably cutting edge. I'm guessing that they look pretty ordinary based on even a rudimentary aftermarket ECU that's at the consumer level these days.
I mean, given their due, they used the best that they had available at the time, and okay, they could probably get to the same result as maybe, or nearly the same result as a modern ECU now, but it would take them a lot longer to get there, and nowadays with the add-ons that an aftermarket ECU could bring to the party with onboard data logging, wideband lambda control, knock control, all these sort of fail safes for like low oil pressure, fuel pressure monitoring for the injector flow rate, these are all things that a modern ECU can do, and it just makes the thing run better. You take for granted. I mean, you look at if you go buy an old car, like buy an old Mark II Escort back in the day, like the thing was a bit shit cold and it was like, chug, whatever. But my God, you go buy a little Ford Fiesta now that's a modern car, you don't even think. It'll just start from cold. It'll run in high altitude. It'll run really good, won't it? And that's all the stuff that the modern engine management can bring if you spend the time to tune it.
Definitely. I just want to focus on one of the elements you mentioned there, because I think this is one that most people wouldn't even understand is an option. So you mentioned fuel pressure monitoring there. And in older ECUs, or where we didn't have the sensors, you didn't monitor fuel pressure, and what you did was foolishly assume that the fuel pressure was either a fixed value, let's say 3 bar, or maybe you've got a boosted engine and you've got a manifold pressure referenced regulator, in which case you're assuming again that the fuel pressure is always 3 bar plus or minus your boost or vacuum. And the key to that is what we're assuming there is we've got a consistent differential pressure across the fuel injector. And why that's important is that the amount of fuel for a given pulse width the injector can supply is relative to that differential pressure. So what I mean is, for a fixed pulse width being sent to the injector, as we raise the differential pressure, as the fuel pressure versus manifold pressure rises, we're going to actually supply a larger quantity of fuel, more massive fuel. So obviously that has an effect on your air-fuel ratio. So that for the longest time, particularly when I first got started, that was just how it was. We never ever monitored fuel pressure. Maybe one of the startup checks, we would temporarily put a fuel pressure gauge on so we could set our base fuel pressure, and after that we were good to go. And it wasn't until I started monitoring fuel pressure with logging initially, and you sort of actually see how much that fuel pressure does vary, particularly with some of the poorer quality fuel pressure regulators. So obviously the knock-on effect there is that your air-fuel ratio is always wandering a little bit, generally not too much, but a little bit, and that becomes more of a problem as our specific power levels creep up. And now these modern ECUs, and this I think goes across the board for most good quality ECUs, will actually take in the differential fuel pressure into the fuel model, and basically they can account for small discrepancies in fuel pressure. Maybe even your fuel pump is starting to die and your fuel pressure is way off. If you've got actually enough injector headroom, the ECU can raise that injector pulse width enough to still keep the air fuel ratio where it should be. So these are like one of my favorite little additions that these modern ECUs bring to the table. And it just sits there in the background. You're driving the car, you don't even know it's happening, but it just does such a nice job. So sorry, I digress there.
No. I totally get it. To be honest, like when you take on some of these projects as well, there seems to be nowadays, you probably find this as well, Andre, like when you get a new application or a new config that you've got to create as a startup file from a blank sheet of paper telling you where all the pins are to making the engine run is much longer now. You know, the amount of numbers you've got to crunch to get the fuel model right and sensors calibrated, and you know, you've got a linear fuel cal done for an injector. And like back to like, you know, we talk about injectors and, you know, volumetric efficiency and stuff like that. Like if you look at a MoTeC, you know, like they have a drop down menu for a linear fuel cal for the injector. Now, to create that linear fuel cal for the injector, it sits on a rig for nearly 2 days straight, pulsing the injector at different battery voltages, different fuel pressures, different openings of the injector, all to spit out a massive report that gets compiled so that you know if the fuel demand is X amount of microliters for a cycle, that the injector has to open. It looks at the fuel pressure, looks at the battery voltage, opens the injector that amount, and it will put the right amount in.
I think that sort of advance in the characterization of injectors, and I'd say probably more so the understanding of the injector. And I think probably, he's probably not the only one who is doing it, but Paul Ure of Injector Dynamics, who I think was ex-MoTeC US as well originally, ex-MoTeC anyway. I think he kind of did a lot of that background that sort of opened a lot of people's eyes to some of the subtle nuances of what the injector does and how important a full understanding and characterization of the injector was. You know, back in the early days, I've tuned ECUs where that understanding just wasn't there, to the point that the ECU didn't even have an injector dead time or battery voltage compensation table. It just didn't exist. So if the battery voltage fluctuated, well, your air fuel ratio fluctuated massively as well. So, you know, take it to the point we're at. It's demanding more and more of the tuner. As you mentioned there, obviously in a lot of these ECUs where this data is difficult or basically impossible for the tuner to come up with. You need expensive test equipment. The manufacturers like MoTeC or whoever it may be are doing this heavy lifting for us and giving us that data, so that simplifies things. But I mean, that's only one element, the injectors we've talked about here. I mean, if we talk about aspects such as charge temperature estimate, which goes sort of a little bit further than just looking at our intake air temperature. What we really want to know is what the charge temperature is as it goes past the intake valve into the cylinder. That's the key element. But there's a transit time from when the air goes past the inlet air temp sensor and gets monitored, then goes maybe through the plenum chamber, picks up heat from maybe a cast alloy inlet manifold. Maybe it's at low RPM where the airspeed's relatively low. So there's an element there of sort of what's the difference in that temperature going to be. So we've got charge temperature estimate tables, which are their simplest sort of look at engine coolant temperature and air temperature, RPM and manifold pressure, and kind of has this very complex table of how it will sort of factor in those elements and give us the actual charge temperature. But for the tuner, that's often difficult to calibrate accurately. So what I'm getting at is, is there a balance here between being able to do an absolutely perfect job versus something that the average tuner is actually capable of tuning and getting those results? So, our ECU manufacturer is essentially purposely dumbing down what they are capable of doing so that the average tuner out there is going to be able to give the customer a good result.
I think the ECU manufacturers are really not pressured. They all want to have the best results for their products. So I think they're definitely necessary, because certainly if you don't have a particular strategy or some sort of calculation available or something like that people want in the ECU, guarantee they'll ask for it. So at least if you have got that option available within the software, you could then fine tune it and use it. And what you often find was, like, back to what I mentioned before about having to occupy all the tables and get like a good base map and sort of some strategies like fine tune before you even start the car. That's where you need to just make sure that you've got sensible numbers in all those tables. And then what you then need to be doing is like occupying your first sort of dyno session with, just some good quality fuel calibration and ignition table calibration and, stuff like that. Because at the end of the day, it's all good having all these control strategies on there and the space shuttle of ECUs, etc. But at the end of the day, if some of the base calibration and sort of mapping of the ECU isn't solid,
the result's compromised.
100%. So many times I've gone to it's been mapped by so-and-so, and you jump on there and the fucking thing's pulling like 30% lambda trim. And all they're doing is relying on closed loop control to get them out of the shit. And you can't do that.
No, you can't. That's great that you just brought that up, because we so often get asked at HPA for, I want a base map for my XYZ engine. And my answer is always, you're actually better to start from basics and build your own base map rather than relying on something you found off the internet from your uncle's, nephew, whatever it may be, because almost without fail, there are exceptions, but almost without fail, every time I've sort of seen a calibration from someone else or one of these supposed base maps that's been brought in from the internet, it's got some kind of baked in error that if you don't know it's there, if you don't fix it, it's going to haunt you. At worst case, it could end up resulting in engine damage, but at best, it's probably going to waste significant amounts of your time chasing your tail, trying to figure out why the hell the thing isn't doing what you expect. Whereas if you start from basics, I know, particularly for novice tuners, it sounds like a daunting task, but it honestly isn't, and it just takes a little bit of time and a methodical approach, and you've got this base map. I think the other thing that people think is that if they don't have the perfect numbers in their base map, the engine, when they crank it for the first time, is just going to explode and all the pistons and rods are going to splay out on the floor. I mean, nothing could be further from the truth, particularly at idle. you can put just about any amount of fuel or ignition timing in it. Worst case, the engine just won't run. It's not going to do damage. So you've actually got a really big window. It's not till you start running the engine at higher load and higher RPM where that tuning envelope gets a little bit narrower and you have to be a little bit more on the money. So I think, just getting away from assuming that someone else has done a good job, because yes, there's some excellent tuners out there, obviously, but they're far and away the minority. They're definitely the exception, not the norm. So chances are, if you're getting a base map from someone else, probably the best place you could put that is just straight in the trash, I believe.
Yeah, I agree. And, commercially, you can't rely on that, can you? Because whenever you touch any number on that map, you're then responsible.
Yes, yeah.
Not 100% for it, but it'll be like, I got that from Dave, EPS Motorsport. And all I maybe done was change the coolant temperature fan threshold limit, to turn his fans on a bit earlier,
Yeah, but all of a sudden the ugly looking fuel maps, that's Dave's responsibility. That was another thing that on that note, when I was running my tuning shop, we wouldn't actually touch up a tune from another tuner for that very reason. And I mean, the odd customer got a little bit sort of antsy about that, because obviously it's going to cost more money, but when you explain it to them, like it's that old story, something goes wrong with the engine and it's the last person to touch the laptop keyboard, that's your fault. So the finger gets firmly pointed. Yeah. And as you say, it might have only been a subtle change, like your radiator fans, but then all of a sudden you're the one who resulted in that blow up. Let's just come back to your Group C car, because I'm quite interested here. We've obviously the price point I've kind of gone over a couple of times. Is this sort of something that plays into the tuning approach in terms of not shooting? It doesn't sound like this is coming from what you've said, but not shooting for the absolute maximum that engine's capable of and what it was running back in the days when it was competitive? Or is it a case of there's so much sort of money and testosterone kicking around in these historic race classes that the customers actually demand the maximum the engine's capable of?
It's a catch-22. A lot of the projects I do with like the Group C cars and stuff like that, it's involved with the engine builder. And like I do a lot of work with a company called X-Tech Engineering, and they manufacture all these engines, and they've got an in-house engine dyno facility, and their knowledge on what they expect from the engine is very realistic. They don't try to reinvent the wheel with massive power figures, and they kind of, they kind of realize that what they've got is what they've got, and, sort of go from there, really. So that's kind of a saving grace, really. And although they're like expensive sort of engines, and, like some of them are priceless, you can't get them again, and all this sort of stuff, to me, it doesn't really matter. Like, I don't really care if it's like Subaru, rally car or a Group C car. Like, at the end of the day, like you got to provide the best tune and the best service with what tools you've got. And you tend to treat every engine the same, really. So, the saving grace is a lot of the Group C projects and the big end sort of projects like that. They will allocate quality time for, a dyno session, a workshop installation session where you calibrate all sensors, you make sure the boost pot works, make sure wheel speed sensors work before you get to, a racetrack, because it costs a lot to test. And I don't care who you are. Like, if you get to a racetrack, you want to be able to, like, check the tire pressures and go. You shouldn't be about changing, shift lights or whatever, before you even get there.
I think that's an area that often tuners were not actually given enough time, that sort of rushed through, because there is a significant amount of time, particularly with a brand new installation, that process of calibrating all of the sensors and going through and physically checking every single one of them is working. That can take a significant amount of time.
Massive time.
But much more than probably most customers would think. But it compromises everything and ultimately wastes time and money if you get onto the dyno, or for that matter, as you mentioned there, to the racetrack and then find out you've got a dead wheel speed sensor, maybe not so critical for the dyno, but that sort of stuff, really, it's worth checking over thoroughly. Now, another project that I wanted to dive into, because I'm personally interested in this, and I know a lot of our listeners will be, another one of the historic engines that I know that you've been involved with is an old Formula One turbo engine, specifically the Hart 415T, and it sort of circles back to our visit to Jeff Page's workshop, because that was the engine installed in Ed Senna's car that we were looking over at the time. So can you give us, I think probably before I get into that F1 turbo era sort of goes down in history as one of the most wild times in F1. The power levels were thrown around 1,500 odd horsepower, 4.5, 5 bar of boost for qualifying, some really crazy fuels that would probably give you lung cancer just by looking at them wrong. And the technology that went into these engines, is a very bizarre time, very different to the modern turbo hybrid era that we've got now. So start with a bit of a rundown, maybe the basics of that 415T engine, because I know it's got one very unique feature.
Yeah, that's a monoblock, isn't it? So I even to this day, I still can't picture trying to put valves, even machine valves, in an engine that you have to go through the bottom. So
it couldn't have been a lot of fun. And for those who didn't follow that term monoblock, what David's meaning there is that the head and block were cast and machined as one piece. So there's no head gasket. It fixes the problem once and for all of lifting heads, though, doesn't it?
Yeah. It's not an issue, is it? Because there isn't a head gasket. But I mean, the valve angles are very shallow, which is good for a race engine, isn't it? To have a shallow valve angle, and they were high compression, and I still can't fathom these. And they all would have been hand machined back then. There was no CNC machines back then, were there? They either broke a lot of stuff, when they were trying to machine them, or they, had really good old school machinists to do a good job. And that particular project, believe it or not, we actually done that in one day, that project. We wired it, got it running, and we mapped it in a day, because we were on a massive time crunch, because that car had to do some film work for a picture and documentary. That was another job that X-Tech Engineering took on, and the thing wouldn't run because of old electrics, and you got no diagnostics. So you don't know what's going on. It could be just one wire. It could be anything, couldn't it? If you take for granted the level of diagnostics we've got available nowadays, so they sort of phoned us up, and we armed ourselves with a MoTeC and a wiring loom, and we went up in the morning, and we got it running by about 11 o'clock. And then we sort of done a calibration for it, and we don't have the petrochemical lab in the back of my EPS van to make up some cancer-inspiring race fuel that give you the results you wanted to. But so we just bought the best commercially available turbo fuel, which is VP import. There's probably other brands that are whatever, but that's another story. And we got into it, really. We sort of use VP import. I have to say that's the only time that I've actually had to swap the engine oil pressure sensor with the engine's map sensor, so we could increase its range, so we could then increase the turbo boost pressure, because we topped out a 4-bar map sensor pretty quickly. And we just found that the more boost pressure that this thing would have, the more the numbers would come, and they did. Okay,
let's talk about some of that. Before we get into numbers and boost pressure, just talking about that fuel, and I don't know exactly what was going into the fuel back in that turbo era back then, but I mean, I know that a few of the F1 teams kind of worked hand in hand with petrol companies to manufacture really special blends of fuel to sort of stave off knock and allow the sort of insane boost pressures they were running. Obviously didn't have access to that fuel, but VP import, I can't remember off the top of my head. I think the octane somewhere above 120. So I've used it in the past. Yeah. It's a pretty special fuel. Was knock an issue with that fuel? Were you sort of walking a tightrope? Did you have to be careful?
Yeah, you still got to be careful, don't you? Because the biggest problem you get when you're using VP imports 120 plus octane, they can't sort of give you accurate measurements above 120, can they? So they kind of it's got this amount of oxygen, this amount of octane. But what you'll find with a high octane fuel with such anti-knock properties in it, you won't hear it knock. It will pass, MBT, before you sort of hear knock, and really you don't want to be getting to the sort of MBT and beyond with such a priceless engine that, has got to go around and make a film the next couple of days, you wouldn't be very popular, that's for sure. So, we just we have knock listening devices on it, and, I've still got the same knock listening device that I used from when I first started tuning, and my ears are tuned into that, aren't they? You have your favorites, don't you?
Definitely.
And you sort of position it onto the engine where you can, somewhere on the inlet side, below the meant to be below the head, but this thing didn't have a head. You can kind of hear the engine come up to peak cylinder pressure and just sort of get all sort of raspy and noisy, and you sort of you're somewhere near the MBT, and then you sort of back it up with reading the plug colors and stuff like that to make sure that you're still safe, and you're going to get a Christmas card, and you're going to send the engine out, and
it keeps running for the filming where it's required.
Yeah, that's right. Yeah.
So where do you end up with in terms of boost pressure and power? Are you able to share those sort of numbers with us?
Yeah, it wasn't as impressive as the numbers that they sort of sprouted with. I think we ended up with about sort of 5.5, 6 bar of boost, and I think it was sort of 850s.
Okay.
850s, 900. So that's still good in all. Still good in all standards, really.
You wouldn't complain.
No, because, you look at the turbo and it's my God, if this had a latest, Zonarotor or, so it'd be so much better, wouldn't it? Because, the thing even had a butterfly in front of the turbo to, shut to create anti-lag. So could you imagine shutting that butterfly on a turbo? Imagine the turbo speed going through the roof. It's that's what they did back then to create anti-lag.
I think it's the turbo technology. It really is essentially exactly the same as what we've seen with the ECU technology, maybe even more so, and even in the 12 or odd years since I ran my drag car, what I've seen with people on that same 4G63 platform making way more power on essentially what is physically a smaller turbo, and I would almost guarantee with better response. I mean, what a time to be alive. The turbos we've got access to now, the airflow that they can support, but the transient response, how they'll come up onto boost and the boost threshold that they can provide even on small engines, it is mind-blowing. So yeah, it would be interesting to see something like that Hart engine running on a modern turbo, but obviously there's a limit to how much you want to change on something of historic significance.
Yeah, exactly. You don't want to wreck something like that.
No. All right, let's move on, and we've sort of talked briefly about dynos. They've come up in conversations so far, and I'm interested. You've used obviously a rolling road dyno, which you've got access to. I'm not sure if you've had experience on a hub dyno. Then with that hard F1 engine, you're talking about an engine dyno.
Engine dyno, yeah.
Yep. So we've got those three options. We've also got road tuning or track tuning. Tell us about the pros and cons of each of those options and where they're suitable.
they're all horses for courses, aren't they? The engine dyno is a great tool for like the engine builder, because it can bolt on, it can be checked for leaks, running correctly in a nice controlled environment. The temperature and all the of the air, the oil, everything like that can be sort of controlled really. So, that's a great tool. I think the best tool still is the rolling road, because you've got so much more that you can test and sign off in one go. Because nowadays a modern engine management system doesn't just run the engine. It controls the gearbox system. It can control, the fuel pumps, it control radiator fans, all these sort of functionality of the car. And when you've got access to a rolling road, you can sign off and test all of those functions. For instance, I was doing some work with a touring car team a couple of years back, and we were sort of on the money with power wise. To them, you can see them come out of a corner, and they'll be, if it was a flat out drag race in one gear, it'd be perfect. But at the end of the straight, we were like a car length back. And we were so frustrated that, like there's got to be something that we're missing here. And that's what the rolling road can then highlight. And that's what we done was I convinced the team, look, give us 2 days of work on the rolling road, and we can sort of have a play and just work out where this deficit is coming from. And basically it was the gear cut strategy. And so we would do like power runs on the actual car and also produce 2 or 3 gear changes. And you could watch the power recovery after the gear change. And that was where we were losing all the lap time from. And basically what it was, there was something in the software. This wasn't a MoTeC. This was a Cosworth Electronics ECU. All it was it had an option to disable the variable valve timing in the event of a gear change ignition cut strategy for a certain amount of time.
It seems questionable.
I mean, I don't know why you would have that in there. And as soon as I found that, we got rid of that, and that transformed the car.
You wouldn't see that on an engine dyno.
No, 100%. And that's why you've got to test. You've got to, like using a rolling road, checking for, gear change cut strategies, and a rolling road where you got like a lot of inertia. You could do a lot of work on deacceleration. So you can get all your overrun fueling correct. And then if all that's roughly in the window, when you do all your throttle blipping for down changes and stuff like that, the engine will respond, and then you'll have a good down change, because it's all good if you have a paddle shift system. Then you go blip with the throttle, it opens up 40%. There's no fuel in there. What's the point? Ain't going to do anything, is it?
So many tuners I see kind of just completely ignore that overrun area of the calibration, because it can be tricky to get to. There's a few tricks I'll talk about in a second, but that overrun where out on the road, you'd either be completely on overrun, maybe just touching the throttle and just holding constant speed. If you're coming down a slight hill as well, it just puts you into an area of the mapping that maybe you can't even get to on the dyno. But particularly as you mentioned there with, now sequential gearboxes with auto blip, that the crispness of the blip, the ability of that blip to work smoothly and quickly, which is the important part there, it really comes down to the overrun calibration being right. Obviously, there's some transient enrichment, accelerant enrichment has to be on point as well. But if you haven't got that, what you end up trying to do, or tuners will end up trying to do, is kind of put a big old bandage on it by changing the accelerant enrichment, where the core problem is that the main fuel mapping in those cells that it's actually accessing on during the blip or pre-blip are just too lean, or maybe massively too rich. The same kind of effect is going to come out. Now, I think the horses for courses exactly, I couldn't have put it better than that. That's the exact scenario. So, if you're on an engine dyno, obvious pro is there. You've got complete access to everything around the engine. So for development work, we're swapping parts, maybe cams, heads, exhausts, etc. It makes perfect sense. You're not actually working in the chassis. One of the things I think that's really easy to overlook with the engine dyno is, in most instances, and I know it's not always going to be the case, but often I see engines being tuned or calibrated with sort of a dyno exhaust system. So it might be the headers as they'll be in the car, but then they're sort of locked off at the end of that front pipe, and then it's just run into a big extraction system. The subtle difference of having that full exhaust system as it will run in the car makes quite a difference often to the calibration, and that's where, when you're tuning on a rolling road or a chassis dyno in general, you're tuning as the car is going to run, so the accuracy there can sort of often be better. The other element there is on the engine dyno, there is no inertia, so you can't get down into those overrun areas. And a little trick that I used to use on my rolling road was, if you're sort of trying to do that very light load overrun area, and normally I'll be tuning in maybe fourth or fifth gear, a gear that's close to 1-to-1. But if you drop down into second gear, the additional torque multiplication that you get in second gear allows you to get access to a lower load area than you could in fourth. Is that something that you're using as well?
Yeah, 100%. Because when you're on an engine dyno, you certainly cannot recreate the car's intercooler system, pipe work. All these have massive effects, don't they? We've had problems before where we've had like a intercooler system, on an application for a turbo, where there was such a massive pressure drop across it. And we only found that out when we got in the car. And that's the joy of the rolling road. You're running it like for like. And I think that's something you need to consider when you're doing a potentially big power project or a development project, that you need to invest in like a little bit of money and a little bit of time to add some extra sensors, and also like pick up points to maybe measure boost pressure or air temperature or something like that, just to see what's going on, really. We done a land speed record car, and this was for a Riley Kestrel. This was, and we used the power plant, the same as my Audi Quattro hill climb car. So I know that power plant can make 900 horsepower. And so we used this in this Riley Kestrel 1930s and all this sort of stuff. And they had problems with the aerodynamics of the car. And of course, they take it to Myra. The thing gets boxed up. There's no holes anywhere. So there's nowhere for the air to go in and out of this engine bay. And of course, it just killed it when we went to do real life testing, because, this poor engine was all boxed up because the aerodynamic guys want to have no side pods. They want to have no air intake ducts, because that's drag. That's all killer stuff, isn't it? And time attack cars are exactly the same. If you haven't got your aerodynamics or your cooling package sorted, then, it is going to be different. Things are going to either run massively hot. They're not going to get the air they require. You ain't going to get the results. And it's just something that you just have to work on, isn't it?
Yeah, absolutely. I mean, I think providing an engine with no air intake may be a fairly brutal oversight by the aerodynamicist. But I mean, I guess at least it would have been aerodynamically clean.
Yeah.
Interested to get your perspective on accuracy and repeatability with a rolling road, because that's where I do see from my own experience some potential deficit. I've seen comparable differences in power session to session because of a different tyre. Obviously tyre pressure has an impact, as does strapping techniques. So how do you combat that? I do a lot of cars that do BMW Championship, and they're all balance of performance type projects. The tyre is the most critical thing to the outright sort of power and repeatability of the project, really, because we've had it before where you've got to aim for, say, 300 horsepower as an example,
and then you'd get 300 horsepower straight away. Then they'd go to the rolling road that the championship requires for them to go. But because they put different tyres on, it's totally different, So it's a hard thing to do, isn't it? And rally cars are the same. They turn up with a gravel rally tyre on a rolling road. It's just a nightmare, isn't it? You're never going to get the horsepower that they expect to achieve, because at the end of the day, it's measuring what it's measuring, isn't it?
I mean, from my perspective, I've said this before, but I think it's sort of with a rolling road. I mean, everyone obviously always wants to kind of convert to some flywheel number so they can go and brag on the internet. I mean, for me, that's less critical, because you go put your car on 5 different types of dyno and you're going to get 5 different results. They don't read the same. There's just differences. It is what it is. What's more important for me is consistency. And what I mean by that is if I do 5 runs without making a change, I want those 5 runs to overlay directly on top of each other, so that when I add a degree of timing and I see a difference, I can be confident that was as a result of the timing, not just as a natural run-to-run variation. So that's really the key for me. So yes, it does become problematic when you've got a customer who's been consistently using you for tuning, and they make some changes which maybe should make more power and bring the car in, but it's on a different tyre, and all of a sudden it's actually measuring the same or 5 horsepower down. That's problematic. But really that consistency run to run, I believe is more critical. And if the dyno measured horsepower kilowatts or fluffy unicorns, for me, I don't really give a shit one way or the other. It's just, again, the same number of fluffy unicorns coming out at the end. That's what I want.
It is 100%. And as you mentioned, it's a tuning tool, and if you know dyno strengths and weaknesses, you could then try to manage a situation. Because when you've got something with big power outputs, by far a hub dyno is the best solution, because you haven't got the slipping, you haven't got the strapping of the car as an issue. None of that is an issue. My God, you can start in like top gear. You don't have to go through the gearbox at all. So that's fine. But when you have got a rolling road, you kind of need to know what sort of tools that you've got and how to manage them. So, whenever I use the rolling road in Northampton, at BRS, I always strap the cars a certain way. It's no bullshit. Like you've got correction factors in it, because I'm not in there to make, like horsepower glory numbers. I just want to make sure that the thing's calibrated correctly. And then, when you're working away on a dyno like that, because you're running it through the tyre is a very, very critical thing. And so a rolling road is not a car's natural environment. So things can heat up too much. Things can sort of not be representative of what it's going to be like on the road. So, you need to give things breaks, do your mapping, complete it all, go and have a coffee, wait for the thing to cool right down, turn the tyres, make sure they're not square by the time you start it back up again. They're all sort of things that you got to do to, then give the final printout results that should be representative to the, machine that you're on, really.
That point you've just made there is really so important. It's difficult even in a really well designed dyno cell to replicate the airflow and hence the temperatures that you're going to get out on the road. And for that reason, even on the best of dynos, I still, wherever possible, like to take the car out and just confirm everything I've seen on the dyno out on the road or at the racetrack. You can do this with data logging, obviously. And it's pretty common that you'll see small discrepancies. Hopefully, everything's at least there or thereabouts, but maybe you might have to make a few percent change to your fueling. I've had situations where the engine has also been, absolutely quiet, not a hint of detonation on the dyno, and you take it out on the road, and particularly maybe on a gear change, it'll get a couple of little hits of det. So the timing might need some tweaking. So, and that's something, again, I don't see too many tuners really doing that. Sort of often it's like close enough's good enough, send it out the door, and hopefully it doesn't come back with a rod hanging out the side of the block.
Yeah, and it also depends on what sort of application and what sort of transmission the car's got and other stuff, because you often get some. We had a S2000 rally car that was a particular car that we had a problem with, and these engines are normally aspirated, massive compression, and they've got a closed ratio gearbox that is like a dustbin with gears in it. And so when you try to map that on the stage or on the road or rolling road, a lot of it, all you hear is transmission, and it's very hard to get right. And we had it in a particular application where we had Alistair McRae driving the car and no problems all year. And then we had another driver, I think it was Mark Higgins, driving it. And then one rally, one engine, rebuild it, one rally, one engine. And in the end, I said, look, we've got to reset. There's something wrong here. I can't picture it, but and so I said, we've got to put it on an engine dyno and then find out what the hell's going on. And we found it straight away. And literally when the engine was running at tick over at 20% throttle, this thing was detonating its head off.
Oh, wow. Right.
It was clacking so bad. And part throttles, quite a lot of load, isn't it? Sometimes part throttles, if you do a lot of BMWs, they detonate a lot with part throttles at low RPM. And that's what it was, because Alistair McRae was driving at such a full throttle everywhere, even road sections and whatever. We never had that problem. And of course, Higgins was trying to be gentle, road sections. The damage was happening. And then as soon as you get on the stage, bang, that would be the sign off of the piston.
Yeah, wow.
And when we had it on the engine dyno with no transmission and no gearbox noises and stuff like that, we could hear the knock straight away. We didn't even have to have headphones on. My God, it was so loud.
Yeah, it does get really difficult with a lot of race applications, noisy dog engagement gearboxes. The other one is, sort of open wastegate dump pipes. All of that just makes it just that much harder. I mean, solid lifters with sort of, pretty loose clearances, that makes a lot of mechanical noise as well, and you're listening to all of that as well. All right, look, David, I think we'll move towards wrapping this up. We've gone pretty long here, and I do want to respect your time. So we'll move on to our wrap-up questions, and that's the three same questions we ask all of our guests. And the first of those is, what's next in the future for you and EPS Motorsport?
Yeah, we're just going to continue on doing what we're doing, really. We're going to, try to get into more manufacturing of our own parts, to help complement the business, so we're going to try to have more car-specific kits available and stuff like that, so that we can sort of get people with the right equipment to start with, because not everybody can wait for manufacturing of a loom and all this sort of stuff. So I want to sort of get more involved in doing all that. And also as well, look, I try to keep an eye on, stock levels and try to buy lots of stock, because all these historic cars and all these other cars, it's not long before sensor manufacturers and other manufacturers stop making things, do they? Mm. And, some of these old cars need these old parts, and same as electrics, so I try to stockpile quite a lot of other stuff like that, really. So that's the main sort of direction we're going to be going in, really. Keep doing the same stuff, really. Have some more fun. And I like to get back to Pikes Peak and, have another go up the hill and maybe in something different. And, so watch your space. So
sounds good. All right. So in terms of your career, it's obviously been a fairly long and sort of creative path you've gone through, obviously helped dramatically by your experience with MoTeC, both in Australia and Europe. Looking back at everything you've done, is there any advice you'd give to a listener, maybe a younger version of yourself, to sort of fast track that career experience, maybe avoid some pitfalls if there have been?
Yeah, I mean, to be honest, I think don't be scared and just roll your sleeves up and get on with it. If you spend all your time looking on Facebook at all these big builds and mega money, this, that, you kind of get a peer pressure of that you have to do all that and you have to have 1,000 horsepower GDR and whatever. But it's like, you don't. do some doing, get yourself a little project car and, like something normally aspirated or whatever, get yourself a little aftermarket ECU and just build the car properly and just enjoy the trade. Like you don't have to be breaking world records at, anything really. Just enjoy yourself. And I think as well, you've got to really concentrate on trying to have relationships with people and your suppliers and stuff like that. Because if you spend all your time just emailing people and whatever, then, you won't get that, step up in life really. You need to be sort of in people's faces and posting pictures of your projects and all that sort of stuff. And that's where you get people involved and you get noticed by other people and you don't know who your next boss is going to be, do you? So, I think take the personal relationships as part of the whole scene as well.
Yeah, like anything, it is a relationship industry. So yeah, I think that's spot on what you've just mentioned there as well. No one knows what you're doing if you're not talking about it or showing people. So don't keep it to yourself. In terms of not needing to start with 1,000 horsepower, absolutely. And one of the cars that I built back in the day, which I still actually really miss, was a little KE70 Toyota Corolla. We'd put in a Toyota 4AGZE bottom end, 1.6 litre, silver top 20 valve 4AGE head, and a hand-me-down HKS GT30 off my old drag car, and that thing was low budget and it was an absolute barrel of laughs, and I learned so much. It had about 3 or 4 different ECUs over its iterations, and I learned so much on that car at a relatively modest sort of budget level, and in the end I think it still went pretty good. It did 1050 on the quarter, so it was no slouch. But that sort of level, what you've mentioned there, starting with a naturally aspirated car as well, while there's absolutely no reason why you can't learn how to tune on an 800 horsepower package, what happens is that the tuning envelope becomes that much narrower, and you do have to be pretty sharp and quick with your changes. A naturally aspirated engine, I mean, some of the lower power ones, you'd just about be hard pressed to break them. So obviously for a novice, that makes a lot of sense to get started there. You're probably likely to do less damage. All right, on to our last question here, Dave. If people want to follow you and see what you're up to, where are they best to do so?
Just EPS Motorsport. We're on like all the platforms with the same name, and websites there available as well. We're on Instagram, and we've got a separate page for the Pikes Peak Project Quattro and stuff like that. So that's the Audi Quattro Revival.
We'll drop those links into the show notes to make it easy for people to find. All right, look, thanks, David. It's been a really great and in-depth chat. I'm sure there's some real value that our listeners are going to get out of this, particularly those who are maybe considering diving into, following their passion into a career as a tuner. So thank you for your time, and we wish you all the best.
No problem. Cheers, Andre.
If you enjoyed this episode of Tuned In with David Rowe, we'd love it if you could drop a review on your chosen podcasting platform. These reviews really help us grow our audience, and that in turn helps us continue to get more high-quality guests. To say thanks, each week we'll be picking a random reviewer and sending them out an HPA t-shirt free of charge anywhere in the world. Also, this is a great place to ask any questions you might have too, and I'll do my best to answer them if your review gets picked. So this week, a big shout out, I'm hoping I'm saying this correctly, T.S. DeLosa. If I've got it wrong, I do apologize. Either way, he said, if you tune cars, you need to subscribe. Excellent podcast that's always packed full of the best people in the industry. If you're into tuning cars, this is packed full of enjoyable knowledge. Well, we tend to agree. Thanks for your kind words, though. It's great that you are enjoying the podcast. We've got some really good episodes coming up, so keep on listening. In the meantime, get in touch with your t-shirt size and shipping details, and we'll fire a fresh tee straight out to you. All right, that concludes our interview. And before we sign off, I just wanted to mention for anyone who's been perhaps hiding under a rock and hasn't heard of High Performance Academy before, we are an online training school and we specialize in teaching a range of performance automotive topics, everything from engine tuning and engine building through to wiring, car suspension and wheel alignment, data analysis, and race driver education. Now, remember, you've got that coupon code. You can use podcast75 at the checkout to get $75 off the purchase of your first course. You'll find our full course list at hpacademy.com/courses. Important to mention that when you purchase a course from us, that course is yours for life as well. It never expires. You can rewatch the course as many times as you like, whenever you like. The purchase of a course will also give you 3 months of access to our Gold membership. That gives you access to our private members only forum, which is the perfect place to get answers to your specific questions. You'll also get access to our regular weekly members webinars, which is where we touch on a particular topic in the performance automotive realm. We dive into that topic for about an hour. If you can watch live, you can ask questions and get answers in real time. If the time zones don't work for you, that's fine too. You're going to get access as a Gold member to our previous webinar archive. We've got close to 300 hours of existing content in that archive. It is an absolute goldmine. So remember that coupon code podcast75. Check out our course list at hpacademy.com/courses.